Hi, today I want to start teaching chemistry, general chemistry. In the chemistry, we study about the matter and the reactions between the matters and the property of the matters. Matter is the anything which has a mass and volume, okay? We can say it occupies space and mass and has a mass. Okay? And if we study about the matter, we can study also about the substance. Substance is the form type of the matter. Okay? Then we can study about the substance. Substance is the form of the matter, okay, which has a defined composition and parts. For example, water. If you see, the water has H2O. In the one molecule of water, I know it has a 2 hydrogen and 1 oxygen atom. Okay? And I know the structure, okay, and the shape of the water molecule. Okay? Now I want to classify the matter or substance. Okay? The best category for the separation of the or classification of the matter we can use two method of the separation. We have two type of separation: physical separation or chemical separation. Chemical separation. Okay? Matter, we can have two types from the method of the separation. Okay? It can be mixture, okay, or pure substance, like water. Okay? We can separate physically the mixture. Okay? But we cannot separate physically the pure substance. Okay? But the method of the separation is different. Maybe we use distillation or filtration or many other methods. Then we can say the mixture can be homogeneous or heterogeneous. Okay? We have homogeneous or heterogeneous mixture. For example, solution is the homogeneous. Okay, for example, we dissolve salt in the water. It is a homogeneous solution. Okay? But we have for example, sand in the water or dust in the water, which cannot be dissolved in the water. It is a heterogeneous mixture. Okay? What is the difference between these two? It is a uniform. Okay? For example, if you have salty water, is all part of the solution is the same. But in the heterogeneous solution, normally it's not the same. For example, if you have suspension, as the example of the heterogeneous solution, heterogeneous mixture, without shaking, after sometimes, for example, it has a times, it will be sediment in the down part and it cannot be uniform. Because of this one, because it is heterogeneous and the effect of gravity, maybe it goes down. It's very important. But for the pure substance, as you know, like a water, we have a two classification. It is the element, and if we have a compound. Compound is the composition of the elements. For example, we have a water, we have two elements with the hydrogen and oxygen. Okay? Both of them we cannot separate physically. For example, I cannot separate, but I can separate compounds with the chemically. But element cannot be separated chemically. Okay? Then mixture can be physical separation, both of them. Pure substance, element and compound. Compound can be chemically separate, but element cannot. For example, if we separate water, we can produce hydrogen gas and oxygen gas. As you see here, we can separate. But element we cannot separate. For example, I have iron, Fe. I cannot separate iron. Okay, we will study about radioactive. Sometimes a particle can, in the isotope of the radioactive isotope, some particle can goes out. It is important. But now we just mention about the classification of the matter or substance, and it is important. And we can classify about the other methods we will study later about the physical properties and the chemical properties of the matter. We will see in the later. And for the physical separation, we have many methods. For example, distillation. Sometimes we want separation of the volatile oil or the volatile oil with the water or other compound which has a different boiling point and melting point. In this situation, we can use distillation. Okay, first we use evaporation, and then we can make a water again, and we can separate with this method. And we can use filtration, or we can use a magnet. For example, if I have the iron with the dust, we can use a magnet, or we can use a sieve for the separation of the, for example, a small particle with defined size with other. For example, we use in the pharmaceutical company also. And this is very important for the chemistry. And I also I want to continue about the elements and compounds. Okay, elements in the periodic table, as you know, in the periodic table we have all of elements. It has a different groups and different rows. Okay. And the same group has the same properties almost, and normally the behavior in the chemical reactions almost the same. And for the element we have a symbol. For example, if we have an element, iron is the Fe symbol. Okay? And every element has an atomic number and atomic mass. Atomic number, it shows the number of the protons, and atomic mass, the sum of the proton number and the neutron number. Okay? And before it's more the basic important things. If we have an element, for example, iron, it has two parts, core and the electron surrounding. Okay? Okay? Which can be, we can say orbital. Okay? Core can be proton, which with a positive charge, and the neutron. The size is the same, okay? But the electron is a very small size, maybe less than 10,000 times smaller than proton. But the same charge, opposite, but with opposite the proton. In this case, the element will be neutral because the number of the proton and electron is the same. If not the same, in this case, the element can be anion or cation. It is ionic form. Okay, and it is important because we will study later for the reaction is important. In the periodic table, you can see all type of the symbol and the shape of the elements. Okay, and it's very important. And the first person who speak about the atomic theory was Dalton. There are many theories about atoms, but one of the basic theory was about element was with Dalton. It shows us the smallest particle of the element called atoms. Atoms can react with each other and make compounds. Okay, and chemical reactions helps us to production of the different type of the compounds, okay? And it's important, and we have to mention about it today, okay? And I spoke about the elements and atom particles. I mentioned about proton and neutron electron. We can test about these particles. For example, proton is the positive charge, and if we have for example, we have a magnetic field or the field with a positive negative charge, and for example we have a cathode or anode, this electron and proton can change the direction, okay, because the proton can go to the negative side and electron can go to the positive charge, okay. And with this method we can find the property of the proton and electron, but neutron it will go directly because it hasn't any charge, and it just goes in the straight form, okay. And for example, Thomson had a practice about the property of electron. He used one a lamp with the cathode and anode, and when the electron go straight in the electromagnetic field, it will go to the positive charge in the anode side, and it shows, for example, if one electron goes from the one direction, if we have a cathode and anode, it will be moved to the positive charge, positive side. It's very important. And also I mentioned about the size of the atom. As I mentioned, there is atomic number in the neutral element. Electron number equal atomic number, and the atomic mass we use relative atomic mass is the sum of the atomic number and the neutron number, and because electron size is very small, and we can delete this in the atomic mass because it's very small. And as you know, the element we cannot for the atomic number or atomic mass we have to use one system. We use 1/12 of the carbon 12. Okay, it is a unit of the 1 unit of the element. For example, when we have hydrogen is just 1 unit of the 1/12 of the carbon 12. Okay, carbon 12 element, we use this particle for the making a relation between the elements. For example, when we have a hydrogen and helium, hydrogen has the atomic number is 1 and helium is 2. In this case, we can say hydrogen has a 1 unit of the 1/12 of the carbon 12 mass, and helium is 2 times more than this hydrogen, and we can say it is a 2 units. It's very important, and we have to care about this. And also I speak about the core and electron. Core, every element has a core, which has a proton and neutron, and it has a very big orbital surrounded with the movement of the electron. We say electron orbital because we don't know where is the electron exactly, but we know it is in the one area inside the electron, inside the orbital, and it rotates. And we will study later about the type of the electron. And I mentioned the charge of proton and neutron, exactly the same but opposite. Proton has a positive and electron is negative. We can use relative charge with a negative and a 1 and a positive one, but neutron hasn't any charge. And also every element, like iron, it has 2 areas, okay, here and here, okay? Here is the atomic mass, and here is the atomic number. For example, if I have a helium, atomic mass is 2, atomic number is 1, okay? from here I can find, for example, is the A equals Z plus N, and we have a 2 and Z is 1, and we can find a neutron. And also we can say neutron is 1. Okay? And I know the atomic number can be equal the electron number, then electron number also is equal 1. Okay? For example, or other example, for example, hydrogen. Hydrogen has a, for example, 1, 1. Okay? As you see here, it has a, and if we have Z equal 1, A equals Z plus N, N equals 0, because 1 minus 1 is 0, and the electron is equal Z is the 1. It's very important. In this case, we can calculate from the symbol also the size and the shape of the element. Okay, every element has a different type of the isotopes. Isotopes is with the same atomic number, okay, same element, but different neutron number. Then Z is equal in the isotope. In the isotope, Z is constant, but A is different. For example, I have a hydrogen. You see? Okay? For example, I have a hydrogen. If you see here, hydrogen has an atomic number, Z is equal 1. Then it is with 1, 1. In the hydrogen, we don't have a neutron. Okay? But in the deuterium, we have a 1 neutron and 1 proton. As you see, the Z is the same but different atomic mass. And all tritium, we have 3 and 1. Okay, you see? It's very easy and very nice. If you see here, the number of the neutron are isotopes. And the lowest neutron number is the most abundant element. For example, hydrogen, we have a most in this form, okay? Maybe 99%. The deuterium is the second, if you see here, but with very small amount. And the tritium is the very low. If the number of neutrons increase, the isotope can be radioactive. We will study later, because we will study about how's the relation between the neutron and the proton in the core, because it can have a radioactive property, which is very important for us, and we have to. I will mention later. And now I want to start study about radioactivity. And as I mentioned, if the number of the neutron increase in the element, in this case, the core is unstable. Okay, it's very important that when the core is unstable, they can produce decay. Okay, it is a different form. Sometimes the element can change. For example, when it produces radioactive decay, it converts to the other element, because in the core there is some conversion between the neutron and the proton happen. Maybe the neutron number increase or the neutron number decrease. The first one is alpha decay. Then we can study about this, and I will write here all of them. The first step is the decay, is the alpha decay. Alpha decay, it is a particle. Okay, this particle, emitted particle, it is helium 2 plus. As you see here, I wrote helium for you. If the particle lost the helium 2 plus, emitted helium 2 plus, this particle is the alpha particle. Okay? Penetration of the alpha particle is very low. Okay? is very important. The penetration of the alpha particle is low. For example, if I have a paper, the alpha particle cannot pass also from the paper, okay? And it has a low energy. But mainly, the element with the atomic number bigger than 83, okay, can emit alpha particle. Okay, it's very easy. As you see here, the helium has an atomic number and atomic mass. As you see here, the number of electrons is 0 because helium has 2 electrons, and the helium 2 plus is without electron. Okay, when helium 2 plus goes out, emitted, absolutely 100%, the core will be changed. Okay, the core will be, we will study later. The core will be changed, and then element can be changed. Okay, this is what the first. The second one is the beta decay. Okay, beta decay has a higher penetration compared to the A. Okay, it can pass from, for example, from the paper or some small or some narrow, for example, clouds or something. It can go past. Okay, it has 3 types because beta decay can be in electron form. Okay, from the emitted particles in electron. Okay, the charge is the negative. If you see, the charge is the negative, or it can be emitted positron. Positron is the same of the electron, okay, but with a positive charge. And the last one, electron capture. When the core, okay, accept the electron from the orbital, okay, what is the relation between two we will study later, okay? The different production of the beta decay depends for the relation of the neutron and proton. Okay? The neutron and proton relation is very important. Okay? For example, if you have a higher neutron number compared to the proton, it can produce electron. When the neutron compared to the proton is small, okay, can produce positron or electron capture. Is very important. Okay? Because as you see here, when the neutron per proton is very small, the proton number is higher. Okay? The core has a more positive compared to the neutron number. Okay, because sometimes we have carbon 12, 6 and 6. You see, the number of the proton and the neutron is the same. But sometimes in some element, the number of the proton is bigger than the number of the neutron. The last one, okay, it is a gamma decay. Gamma decay has a highest penetration. It can very good penetration. It produces gamma photon, electromagnetic wave. It is very important, and usually for this situation, with this case, we need an element with higher excitation. For example, we have uranium or polonium. In this case, we can produce proton. It has a higher energy. We will study later, and it's very one of the important things for us. And in the science, it is one of the important things. For example, we can use in the pharmaceutical company or from the positron. We can use for the PET positron emission tomography. For example, we give for the patient some, for example, glucose with the positron effect, radioactive positron, for example. And because the cancer cells loves the more glucose, this glucose with the positron go inside the cell, and in this case, when we use the tomography with the scan of the body, we can see more emission from this type of the cell. Or we can, for example, use from the, for example, this positron, or we can use from the carbon 14, for example, for the find of the half-life of the mummies, and some, for example, some, because every carbon half-life is the carbon 14 half-life is the 5,730 years. Okay, when, for example, we find some fossil or something from the 10,000 years ago, we can calculate with the amount of the carbon 14 remained in the body. Okay, because the life animal or person has the same as constant amount of the carbon 14, but after die it decreases every 5,730 years to half. And we can, when we study, when we can measure this one, we can find for the life of the, for example, life of the, for the animals, fossil or something in the archaeology. And it is very important, we can also use gamma decay for the therapy, for example, for the killing the cancer cell and destroy the, for example, destroy the cancer cell, because sometimes we cannot use then in the situation we can use this alpha beta gamma decay for the diagnosis, like we can use a PET, or we can use, for example, iodine. For example, if we have iodine 131, we can in the small dose we can recognition of the thyroid cancer, because thyroid use iodine. Okay, in the low dose we can suppression of the thyroid gland, the production of the, for example, thyroid, or for the killing the cancer cell in the thyroid. Or then for the higher dose we can, or we can use gamma photon, as I said for you, for the killing cancer cell with, for example, cobalt 60 and or iodine 131.